Hey Wrestlings! We are students from Cavite State University, main campus.
College of Engineering and Information Technology.
Taking a degree on Bachelor of Science in Electronics and Communication Engineering. For this video, we will be relating our program to the subject physics using a concept map.
The Bachelor of Science in Electronics and Communications Engineering, or BSECE, is also known as Bachelor of Science in Electronics Engineering, is a 5-year degree program in the Philippines that is mainly concerned with the conceptualization, design, and development of any electronic computer or communication products, systems, services, and processes. This stream of engineering deals with analog transmission, basic electronics, microprocessors, solid-state devices, digital and analog communication, analog integrated circuits, microwave engineering, satellite communication, antenna, and wave progression. It also deals with the manufacturing of electronic devices, circuits, and communications equipment. What about physics, Jeff?
Physics, on the other hand, is the branch of science concerned with the nature and properties of matter and energy. The subject matter of physics, distinguished from that of chemistry and biology, includes mechanics, heat, light, and other radiation, sound, electricity, magnetism, and the structure of atoms. Right, Philip?
Both of them giving a brief background of the two things we're going to relate is a good start in making our concept map. That's why we're going to place our program as the main concept of our map. Having ECE in the middle, we branched out 3 fields that relate to the development and application of the electronics engineering, science, and technology, which are operation and maintenance, manufacturing and production, and research and development. First, let us dig on our first branch, which is operation and maintenance. Operation for ECE is the process of running or managing an electronic system, network, services, and peripheral facilities intended for the transmission, reception, and delivery of intelligence by wire, radio, fiber optics, and other futuristic media. Whereas maintenance is the proper upkeep of electronic system and equipment so as to attain maximum safety and meet the desired grade of service. For ECE, the scope of operation and maintenance includes any communication systems or network and any broadcasting systems or networks. That's why we branched out communication and broadcasting from operation and maintenance. Broadcasting is the distribution of audio or video content to a dispersed audience via any electronic mass communications medium, but typically one using the electromagnetic spectrum, which are radio waves, in a one-to-many model. Communication, on the other hand, is the meaningful exchange of information at a distance by technological means, particularly through electrical signals or electromagnetic waves. Since both broadcasting and communication deals with signals, we branched out signal processing from the both of it. Signal processing deals with the analysis and manipulations of signals. Signals can either be analog, in which case the signal varies continuously according to the information, or digital, in which case the signal varies according to a series of discrete values representing the information. For analog signals, signal processing may involve the amplification and filtering of audio signals for audio equipment or the modulation and demodulation of signals for telecommunications. For digital signals, signal processing may involve the compression error checking and error detection for digital signals. From signal processing, we branched out a more specific field which involves telecommunication engineering. Telecommunications engineering deals with the transmission of information across a channel such as coaxial cable, optical fiber, or free space. Transmissions across free space require information to be encoded in a carrier wave in order to shift the information to a carrier frequency suitable for transmission. This is known as modulation. Popular analog modulation techniques include amplitude modulation and frequency modulation. The choice of modulation affects the cost and performance of a system, and these two factors must be balanced carefully by the engineer. Once the transmission characteristics of a system are determined, telecommunication engineers design the transmitters and receivers needed for such systems. These two are sometimes combined to form a two-way communication device known as a transceiver. A key consideration in the design of transmitter is their power consumption, as this is closely related to their signal strength. If the signal strength of a transmitter is insufficient, the signal's information will be corrupted by noise. To master the processes happening in telecommunications, there are particular physics topics that plays a big role on its processes, which we can branch out from it. These are optics, condensed matter and material physics, and magnetism. For optics, optics is a branch of physics that deals with the determination of behavior and property of light, along with its interaction with matter and also with the instruments which are used to detect it. Optics and electronics are partnering and complementing each other in meeting the demand for strong advances in display technology and information technology, and thus enabling the information age. There are 5 major technology segments in which optics plays a major role or has the chance to do so in the future. One of them is information transport over long distances, through a large network under the ocean, across continents, and in the local networks of the telephone and cable television systems. For this, optical fiber transmission is already the technology of choice, with a clear edge in cost and performance over competing technologies such as coaxial cable or satellite communications. Optical processing, including switching and networking, is another segment in which worldwide research and development hopes to open up new markets. A third segment is the storage of information, where technology has to meet rapidly increasing demands for more and more storage capacity. Optical techniques are a strongly growing complement to the traditional magnetic storage. A fourth segment is the display of information, for which optics is the intrinsic, unavoidable link between the human eye and the electronics of a television or computer. The fifth important segment is the interface between electronic machineries and information recorded on paper, which includes printers, scanners, and copiers. Moving on to condensed matter physics is the field of physics that deals with the macroscopic and microscopic physical properties of matter, especially the solid and liquid phases which arise from electromagnetic forces between atoms. More generally, the subject deals with the condensed phases of matter, systems of many constituents with strong interaction between them. Condensed matter and material physics is the branch of physics that studies the properties of the large collections of atoms that compose both natural and synthetic materials. The roots of condensed matter and material physics lie in the discovery of quantum mechanics in the early part of the 20th century. Because it deals with properties of matter at ordinary chemical and thermal energy scales, condensed matter and material physics is the subfield of physics that has the largest number of direct practical applications. It is also an intellectually vital field that is currently producing many advances in fundamental physics. 50 years ago, the transistor emerged from this area of physics. High-temperature superconductivity was discovered by condensed matter physicists, as well as the fascinating low-temperature states of superfluid helium. Scientists in this field have long-standing interest in electronic and optical properties of solids and all aspects of magnetism and magnetic materials. They investigate the properties of glasses, polymeric materials, and granular materials, as well as composites, in which diverse constituents are combined to produce entirely new substances with novel properties. Condensed matter and material physics has played a key role in the technological advancement that have changed our lives so dramatically in the last 50 years. Driven by discoveries in condensed matter and material physics, these advances have brought us the integrated circuit, magnetic resonance imaging or the MRI, low-loss optical fibers, solid-state lasers, light-emitting diodes, magnetic recording discs, and high-performance composite materials. These in turn have led to the spectacular growth of modern computer and telecommunication industries and consequently to the information revolution. Lastly, magnetism. Beginning with the ancient mariner's compass and continuing with such applications as automobile starter motors, refrigerator magnets, and computer hard disk drives, the importance of magnetic materials in a wide range of technology uses steadily grows. Such materials display a host of fascinating properties of scientific interest, Many of these properties have proved to be useful in technological applications. The interplay of science and application has made magnetism an extremely exciting segment of condensed matter and material physics. The last decade had seen acceleration in the advances of both the technology and science of magnetism, advances that have set the stage for even more profound discovery and technological developments in the near future. The field of magnetism enjoys an unusually strong technology pool, second in condensed matter and material physics only to that of semiconductors, particularly silicon. Electromagnetics is an in-depth studies about the signals that are transmitted in a channel, wired or wireless. This includes basics of electromagnetic waves, transmission lines, and waveguides, antennas, its types and applications with radio frequency and microwaves. The most common wireless technologies use electromagnetic wireless telecommunications, such as radio or infrared signals. With infrared waves, distances are short, such as a few meters for television remote control, while radio waves can reach as far as thousands or even millions of kilometers for deep space radio communications. It encompasses various types of fixed, mobile, and portable applications, including two-way radios, cellular telephones, personal digital assistants or PDAs, and wireless networking. Other examples of application of radio wireless technology includes GPS units, garage door openers, wireless computer mice, keyboards and headsets, headphones, radio receivers, satellite television, broadcast television, and cordless telephone. Less common methods of achieving wireless communications include the use of light, sound, magnetic, or electric fields. Summing up the branch of operation and maintenance, we have ECE, operations and maintenance, broadcasting and communication, signal processing, telecommunication engineering, optics, condensed matter and material physics, and magnetism. Moving forward to the second branch, let us have Ja to discuss it to you.
That was a very long discussion by Philip. Prestins and I hope you're still there listening, as I discussed the second branch, which is manufacturing and production. Manufacturing and production is the process of producing, forming, or fabricating electronic equipment or related components, parts, devices, and accessories. The scope of work for this is the management and supervision of the production or fabrication of electronic equipment or related components, parts, devices, and accessories. Research leading to or resulting in the design or manufacture of new or improved electronic equipment, components, devices, techniques, and procedures. And testing and quality control of electronic products. From this branch, we can branch out two general things: electronic devices and appliances. Electronic devices are components for controlling the flow of electrical currents for the purpose of information processing and system control. Prominent examples include transistors and diodes. Electronic devices are usually small and can be grouped together into packages called integrated circuits. Whereas an appliance is defined as a piece of equipment or machinery that is used to perform one or more household tasks, which describes a number of items in the home, including your dishwasher, washing machine, refrigerator, and stove. These two can be connected into one physics topic, which is electricity. Since majority of all the electronic devices and appliances nowadays uses electricity. A basic definition of electricity is a form of energy that results from the flow of charged particles. Electricity being the flow of moving electrons, it should be known this produces a resultant called electrical current. This current allows objects to work in tangent with each other by flowing through conducting materials connecting them. The path that the electrons flow through called a circuit. Circuits connect all of our electronic devices, allowing us to live the way we do today. Today, the modern sources of entertainment, starting from listening to music from MP3 players, watching television, playing movies in DVDs, or VCDs or VCRs runs on electricity. Constructions of buildings and structures for the convenience of people require electricity in every step. Building houses, installing gates and windows, welding of materials require current electricity to operate the machines. Reaching places or communicating from a different corner of the world is only possible because of electricity. The street lights on the road use electricity to function. Even the pool requires electricity to heat the water in colder regions. The lawn mower, which is used to cut grass, uses electricity to operate. The water sprinkler for the grass on the lawn uses electricity as well. Starting from toaster to refrigerator, microwave, washing machine, dishwasher, electrical chimney, and many more appliances which are simply to use and made for the convenience of day-to-day activities use electricity to function. For the production of various materials, the factory uses heavy machinery which always run from electricity. Even the magnets, which are of giant-like structures, require electricity to keep it charged for lifting heavy metals. We go to work in offices in which most things run on electricity. The lights, lifts, AC, coffee machine, ID card reader, biometric scanners, and everything else requires electricity. Electrical energy comes under renewable energy, and we can produce it using most of the natural resources available to us. Today, things which were running on fossil fuels, such as cars and bikes, are now made in such a way that it runs on electricity, like solar powered, which will be more convenient in the future. Going back to both electronic devices and appliances that uses electricity, from the electronics devices we can branch out examples like radio, computers, and mobile phones, 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 which can be connected to our first branch discussed by Philip, which is operation and maintenance, since it branches to signal processing that is a major function of these electronic devices. On the other hand, we can branch out refrigerators and air conditioning unit from appliances which are heavily used in discussing a physics topic, which is thermodynamics. Thermodynamics is a branch of science which deals with the study of heat and temperature and the relation to other forms of energy. It applies to a variety of science and engineering topics such as chemical, physical, and mechanical engineering. This branch was basically developed out of a desire to improve the efficiency of steam engines. Study of thermodynamics involves the zeroth law of thermodynamics, first law of thermodynamics, second law of thermodynamics, third law of thermodynamics, Boyle's law, and Charles' law, along with various properties and functions that unravel many materials as well as spiritual mysteries of nature. Summing up our second branch, manufacturing and production, we have ECE, then electronic devices and appliance, connected to electricity. Under electronics devices, we have radio, computers, and mobile phones. And then under appliances, we have air conditioning units and refrigerators. Then we connected to thermodynamics. That's it for the second branch. Let us welcome Jeff for the third branch.
It's been so exhausting listening to those things, isn't it? But guess what? We're on the last branch. Thanks to Philip and Jack for making it easier for you to understand the wonder behind physics. So, for our third branch, we have research and development. Since CCE is originally derived from electrical engineering, most of its scope mirrors electrical engineering scope. The practice of research and development for ECE consists of specialized investigation and evaluation of operational and/or laboratory data leading to or resulting in the design/manufacture/production or development or control/measurement of new or improved electronics systems, equipment, and or electronics components, devices, techniques, and procedures. Its scope of work covers formulation and development of new electronics products or system from its conceptualization to utilization and commercialization. Improvement of electronics products or systems to improve reliability, usability, and cost effectiveness. Systems analysis, coordination, and evaluation of quality control programs in business and industrial establishments. Research and development of new, effective, and efficient systems and or techniques of information, transmission, and reception, robotics, computerized or computer-aided work automation, and manufacturing. And research and development in the effective and efficient application of electronics in education and information dissemination. Since research and development is too broad, we chose two important fields, which are power transmission and transportation. Let us talk about power transmission first. Typically, power transmission is between the power plant and substation in the vicinity of a populated area. This is distinct from electricity distribution, which is concerned with the delivery from the substation to the consumers. Due to the large amount of power involved, transmission normally takes place at high voltage, 110 kilovolts or above. Electricity is usually sent over long distance. Through overhead power transmission line, power is transmitted underground in densely populated areas, such as large cities, but is typically avoided due to the high capacitive and resistive losses incurred. Related to power transmission, we can branch out physics topics from it, which are alternating current and inductance. AC power transmission is the transmission of electric power by alternating current. Usually, transmission lines use three-phase AC current. In electric railways, sometimes single-phase AC current is used as traction current for railway action. Today, transmission level voltage are usually considered to be 110 kilovolts and above. Lower voltages such as 66 kilovolts and 33 kilovolts are usually considered sub-transmission voltages that are occasionally used on long lines with light loads. Voltages less than 33 kilovolts are usually used for distribution. Voltages above 230 kilovolts are considered extra high voltage and require different designs compared to equipment used at lower voltages. Moving on to inductance, there are a variety of methods to charge an object. One method is known as induction. In the induction process, a charged object is brought near but not touched to a neutral conducting object. The presence of a charged object near a neutral conductor will force or induce electrons within the conductor to move. The movement of electrons leaves an imbalance of charge on opposite sides of the neutral conductor. While the overall object is neutral, there is an excess of positive charge on one side of the object and an excess of negative charge on the opposite side of the object. Once the charge has been separated within the object, a ground is brought near and touched to one of the sides. The touching of the ground to the object permits a flow of electrons between the object and the ground. The flow of electrons results in a permanent charge being left upon the object. When an object is charged by induction, the charge received by the object is opposite the charge of the object which was used to charge it. On the other hand, for the branch of transportation, we branch out aviation telecommunication engineering and aviation electronics engineering. Aviation electronic engineering and aviation telecommunications engineering includes research and work on electronics and aerospace topics. Aviation telecommunication engineers include a group of specialists who have a lot of information about the flight, such as meteorological data, some specific information, etc. Through the available platforms, such as AFTN, etc., at the disposal of the aircraft itself or parts. Specialists in this field mainly need knowledge of computer, networking, IT, and physics. Their work are in organizations and companies in the air and space. Before, during, and after the flight, the aircraft needs equipment and platforms that meet many of its needs, such as navigation, information, communication, and monitoring systems. Therefore, aviation telecommunication engineering can be connected to the branch of telecommunication engineering that is discussed on the earlier part of this video. Consequently, aviation electronic engineering can be connected to inductance that was discussed a while ago. Since few electronics designs areas benefit as much from the use of inductive components as the avionics industry, yet many people feel uncomfortable using these parts or fail to see their true value. Everyone is familiar with the inductors used in the radios, tuned RX and TX circuits. But inductive parts have far wider application in modern avionics designs, as more designs need to withstand high transient spikes on DC power and other lines, and more switching DC to DC converters are used, and more sophisticated audio designs become the norm. Inductors and transformers are playing an increasingly critical role in successful new avionics systems. Inductive parts can provide true galvanic isolation, dramatic suppression of high-frequency interference, work as energy storage in voltage converters, and provide almost lossless impedance matching and voltage changes. Their ability to provide noise-free AC voltage gain without power is an especially useful and unique property. With the recent surge in the popularity of switching converters, many more universal inductive parts have become both inexpensive and readily available to allow their use in all types of power supply circuits. In addition, several manufacturers have also generated a wide range of standardized transformers for audio isolation and impedance matching. This is a huge chance from even 15 years ago, when the choices for these parts were relatively limited. Parts were quite bulky and parts costs were comparatively high. Summing up the third branch, we have research and development, power transmission and transportation. Under power transmission, we have alternating current and EM inductance. It can also be connected to thermodynamics. Under transportation, we have aviation telecommunication engineering and aviation electronic engineering, which is connected to telecommunication engineering and inductance respectively.
What a long discussion for the relationship between physics and ECE. For a great wrap-up for this video, let us see the whole concept map including all the branches and its sub-branches.
Don't forget to watch the videos of our classmates regarding to the same topic.
It's really hard to understand the relevance of the things being taught to us if we don't know its relation to each other. But even though it's hard, don't stop learning. Instead, just take a rest. That's it for our video. If you're new to this channel, don't forget to hit the like and subscribe button.
And don't forget to click the notification bell to get notified whenever we post a new video.
Also, comment down below your thoughts about this video. Until the next Learn with Rest, bye Wrestlings!
Learn with rest. Bye Wrestlings!
Bye, wrestlings!
Somewhere over the rainbow, bluebirds fly, and the dreams that you dream of, dreams real.